and what kind of products you browse, how long you stay on that page, and what you click after you browse a particular page. All that information is fed into a system, so the computer system can actually try to figure out what interests you. So when a new product comes out, they will send you a message and say, "I think you will probably be interested in this," and I'll be creeped out because of that. Yep.
You know that three major companies are SCREEN, Information Security Specialists, which is Northrop, General Dynamics, and Lockheed Martin.
Okay. And a bigger, but thanks for mentioning that, because computer security is going to be a big field too. Now, unlike the other industries where it is all driven by money and stuff like that, computer security is driven by demand. Why do you think there will be an increased demand of computer security experts?
Because the experts will always need to be re-updated, because there's always going to be some new guy coming along and trying to disrupt the security for government reasons,
Exactly.
or business reasons, or whatever else.
Because you have an active adversary. It's not even competition like in the commercial world. Amazon.com comes up with this new feature on their website, so another online merchant will try to match that and be competitive. It goes well beyond competition when it comes to computer security, because you have an adversary in that case. And the adversary is not just another corporation, is not another individual. We're dealing with entire countries. Okay? And it will just go up the next level easily. Okay, both sides will just kind of step up. One side gets stronger, the other side will get even stronger, and this is an arms race. It really is the same thing as an arms race, except it does not involve any hardware. Okay, now if it does not involve any hardware, like ICBMs and stuff like that, it really levels the quote-unquote playing field a lot. Okay, now if you think about it, how many countries can build ICBMs? Accurate enough to be effective. Not just I can launch something over to another continent. Not a whole lot of countries. Okay, about 5. Okay, because the technology involved, the infrastructure involved, and all that stuff. Building a rocket is not that simple. Okay, just building a rocket that can launch without falling over and exploding itself is not that easy.
Well, a good example is the world's largest military is China. They just finally launched their first aircraft carrier.
Yep. Well, it's actually not their own aircraft carrier. They bought it from the Russians without the user's manual or warranty, and then they had to do a whole bunch of work to make it functional, okay, to begin with.
It's a refurbished aircraft carrier.
Yes, and it it only allows vertical takeoff vehicles too. It doesn't have a landing.
They fixed it where they can do straight shots now.
Oh, okay.
They can do catapults.
Okay. But it's still, compared to the aircraft carrier of the United States, this is like completely dated technology.
Also kind of small in comparison.
Yeah, it's very small. It's about the size of what France has.
But if they have smaller airplanes, it's okay. Yep. But that tells you something about in terms of military conflicts or arms race. It takes a lot of resources, and not a whole lot of countries can quote unquote play in that game. But yep, go ahead.
No, go ahead.
But in terms of not electronic warfare, but programming and computer security, how much does it take to become quote unquote a superpower? Not a whole lot.
One really determined individual. One really determined individual.
Well, you usually need a group of people, so bright people help, but you need a group of people. But nonetheless, you do not need hardware. Okay, you don't need that $5 million mill to crank out those propellers that are completely silent. Okay, you don't need the ability to machine titanium to a high precision. You just need computers, not even particularly fast computers, depending on what people are doing. Okay, so that's why computer security is going to be a very rapidly changing field, and I think that's going to be one of the things where there will be a lot of employment opportunities, but at the same time there's also a lot of requirements to work in that field. Yep.
I think that you're looking. I think with looking big though, the small scale, more people are using things like tablet computers, and than any time prior to today.
Mm-hmm.
So going to be looking at, people are going to start more and more putting their credit card information and other personal information
Yep.
on those particular devices.
Absolutely.
And programs are going to need to be able to be developed to secure that.
Yep.
And you're going to have to constantly fight just the small time hacker trying to get to that information.
That is correct. Yep. Absolutely. All right. So we are now finally getting started with this part here. Developers and algorithms. Okay. This is actually my own material. And this is what you need to do to study for the class. You basically just need to hit all the links on the website. I'm not gonna talk too much from the notes here, but I will point out all the important parts. The important part here is computer and software. It is now everywhere, and more things are now run by computers, and they are programmable. Okay? This is not a phone. This is a computer pretending to be a phone. Okay? Being a phone is not its primary job anymore. Okay? I use it mostly as a computer, and occasionally I use it to call some other people. What else do we have have computers now? Cars. Okay, just about any car that you buy off the lot probably has several computers on it for different purposes. What else?
Calculators.
Sorry?
Medical.
Medical. Okay. Pacemakers now are computer programmed. Okay, a lot of
when you operate, doctors can actually get into a website, say get into the hepatic system or something like that,
Mhm.
and have everything available there for him if he needs a question. Instead
they-
of stopping the operation process, and he can actually perform the operation
remotely.
Yes, externally.
You just have to make sure the network connection is very good. But at some point, you know what? At some point, the technology will get to the point where it is not remote anymore. It is automated. Okay. Many of you, I think, will live to that day. You'll probably forget me because I'll be long dead by then. But many of you will probably live to the day where you can go to a hospital. Not only is the diagnostics done automatically, you just walk into a room. You don't even have to undress and get yourself into the machine and stuff like that. You just kind of walk past a hallway, and the sensors and all the machines will get enough information about you. By the time you're at the end of the other side, they will know what to do with you. Okay? And then if you need any type of surgery, any procedure done, guess what? That can also be done automatically. There's no doctor involved, whatsoever anymore. Yep.
How do you think quantum computing is going to affect the programming world?
Quantum computers will be a big disruption force, in computer science, because up to now, all the computer science, all the theories that we have are based on deterministic machines. In other words, you're here. This is the state, the current state. You perform this operation. 100% of the time, you end up here. Okay, so it's completely deterministic. Now, the program can be very complicated, millions and millions and millions of lines, but nonetheless, if I give you the current state and I tell you what instruction I execute next, it always brings you to this other state that is predictable. But with quantum computing, it is not like that anymore. In fact, you can be in multiple states at the same time, and the transition is not deterministic. So I think that will really, really change computer science as a whole, and it will take computer scientists, theorists, many years to really come up with the tool set that the rest of the industry can use, to practically make use of the technology. So we are looking, but when that happens, I think it will also change the future of what we consider as computers and their capabilities, a whole lot. So what you're talking about is quote unquote, without not intended as a pun, is a quantum leap from what we have at this point. Yep, go ahead.
The other thing you said that when developing websites, scripts were used to develop websites. You basically meant that the sites themselves were designed and placed online, but every time a new product was introduced, introduced, a script would be introduced to place it on the site?
No, not what? Okay, if you're introducing a new product, so let's say you're Amazon.com, okay, and you're trying to stock a new item, you're trying to sell a new item.
Right.
What is involved in that case is somebody has to put in the information of the new product through an interface that we don't see. Okay, so they have to sign into a particular interface of Amazon, probably remotely, and then they just have to input the picture, upload the pictures, update the description and stuff like that, and then when you click or submit, that product becomes available to everybody, using Amazon.com.
Okay, but let's say the site, they're repositioning using different color scheme and different logo and all that stuff. That wouldn't be handled through scripting, would it?
Okay, it depends on the complexity of the new interface. Sometimes it can be done without any type of coding, just by changing the cascading style sheet. You can create a whole new look already.
We know that, but you're doing it all via scripts, via Dreamweaver?
I don't think they use Dreamweaver. I think they have their own scripting
Something
architecture.
beyond.
Sorry?
Oh, something beyond that program?
Dreamweaver is really, it cranks out kind of canned code. I don't think Amazon can run on canned code from Dreamweaver. Yep.
Are you talking about like data mining?
No, I think he's just talking about the website itself. How do they write the scripts, for Amazon.com?
Okay.
But data mining is also a big field, because people want to extract as much information from data as possible. All right. So computers and software, it is very important. For the most part, we actually have the hardware that we need to do all the things that we want them to do. But what is lacking is the software. Think about driving, okay? Think about the autonomous vehicle. Remember we just mentioned the autonomous, taxi cabs and stuff like that. How do you drive? Do you drive with a LiDAR and all the other extra stuff, to navigate, on in your daily driving? No. How do you drive? You got two eyes. You have your hands, feet. Yep, and that's it. Okay. So why do you think an autonomous vehicle require all these extra stuff instead of just two cameras, which resembles our eyes? Why do you think they need all these fancy equipment?
Because it's basically what we were doing as kids. We have to learn how to use the hardware. It's trying to teach the computer how to properly use the hardware.
It's not easy. It is not easy. Okay. Now, if you think about it, we got two eyes, right? And the resolution of our eyes is not really all that impressive. There are many animals out there with much higher resolution and sensitivity. So our eyes is okay, but it's not really that special. Okay. But what we can do with our eyes is amazing compared to what computers can do with only two cameras. We can, do depth perception, which is important in driving. And more importantly, we can process our images in a way that we can recognize things like right away. When you drive, you have to gauge the distance to the car in front of you. You can gauge that, pretty intuitively. Most people can do it. You can look at a road sign. Okay, you can distinguish a road sign from a pedestrian. Guess what? To a computer, it's really hard to do that. You can look at the contrast change of the curb to the road, and to you, it's easy to tell, oh, this is not